Hello everyone, hope you all are doing well. In today's video, we will be covering our planned series 30th question, which is number of island. And it's a very good question which is based on our graph traversal algorithm. So let's read the problem statement. Given a m cross n 2D binary grid which represent a map of 1 which means land and 0 indicating your water, and we have to return the number of islands. An island is surrounded by water and is formed by connecting adjacent land horizontally or vertically. You may assume all four edges of the grid are surrounded by the water. Means any cell which is out of the boundary of m cross n grid, we can assume that it is just water. And we just have to care about what's inside m cross n grid. So let's see how can we approach towards the solution. Okay, so our main aim is to find the total number of islands. Okay, and we are given a grid of m cross n size, where 1 is indicating your land and 0 is indicating your water. And the island is formed by connecting adjacent lands either horizontally or vertically. Like in this example, you can say see that your island is this. You can see there is one island. This also. This is your one island. But other than that, you can't see any other island here because as you can see, each of the land is connecting to its adjacent cell. Like here it is connecting horizontally and here it is connected vertically. So that's why we consider this whole as a one island. And in this case, if we consider this example, so in this case, okay, this is one land. Okay, so this is one island. But is there any more land which can cover this island? As you can see, there is no other land. Here is one, but it is actually diagonally, so we can't consider it. We only consider a land which will be a part of an island if it is either comes vertically or horizontally, but we can't assume a land is a part of an island if it is diagonally. We only consider vertically or horizontally. Okay, so it is one island and it is the second island. As you can see, there is no other adjacent land uh, beside this. So this will be alone a island. So we find two islands so far, and there is also one more island as you can see here. So this is the third island you find, and other than that, there is no other adjacent land which can be become a part of this island. So you can see, as you can see, there are a total of three islands which can be formed here. So now how will we approach towards the solution by using this? Well, we can use the depth first search approach to solve this problem, which is also known as DFS approach. But so what happened in this approach? Well, in this approach, first of all, we visit a cell and then we visit its neighbor. Okay, and when we visit its neighbor, then we start visiting its neighbor of its neighbor. For example, you can say first of all we start from this cell. Okay, it's a land. Since one is indicating your land, so we will start exploring its neighbor. So who are is its neighbor? So this sits right side it's is its neighbor. Okay, as you can see it is also a land. So we'll again start exploring its neighbor. Okay, so its neighbor is again this one because it's also a land. Then again we start exploring its neighbor and again we find a land. Then again when we start exploring its neighbor we find that okay, so now it's not a land, it's a water. So we not go beyond that. Okay, so it's our boundary condition that we only traverse the neighbor which are actually a land. Okay, we will not traverse uh, any neighbor which is a water. Here zero indicating water. So we simply not explore it further, but we what we do is we simply backtrack. Okay, we go back to our parent of this. Okay, and now we will start exploring its other neighbor. Like it's this zero is its right neighbor, and now we can move either to four direction. Okay, here we can either move to four direction, either right, down, or left or up. So we explore the right of this neighbor. Okay, we explore the right of this its neighbor. So now since we explored its right, now it's time to go towards the down. Okay, so now we will start exploring its down neighbor. Okay, we again find one neighbor. then again we start exploring its right. Okay, we find water, we will backtrack again to its neighbor. Okay, now again we will try to explore its neighbor. Again we find water, and here again on the left side we again find water, so we will backtrack to its again. Okay, so we backtrack to it again, this one. Okay, now since we have already seen its right neighbor and we have seen its down neighbor also, so it's time to go upward, but we don't find anything on the upside, so we simply go back to this one. Okay, we simply go back to this one. Okay, now we'll start exploring its neighbor. So we go downwards, we again find water, so we can't explore it further, so we again backtrack to this one. Okay, now we backtrack to this one, so I already go towards the right, so it's time to go down. Okay, so I go down and I found a land, so I will visit this neighbor and I will start exploring this one. Okay, I will go towards the right one, but I see that okay, here is water, so I backtrack again to this one. Okay, now I will go towards the down one. Okay, now I will again find land, so I will start exploring this neighbor. Okay, now I will go towards the right, but I find water, so I will backtrack to this one again. Now since I will come back to this one, now I will start and I already explored the right side, so I will start exploring downside. Again I find water, so I backtrack to this one again. Now I will go towards the left side. I okay, now this time I find, okay, this time I find land. Okay, so I will visit this neighbor. Now I will go towards the downside. I see there is water, and if I go towards the right, towards the left, I see there is nothing on the left side. So I will again backtrack to this one. Okay, now I will go towards the upside. I find land. Okay, now I find land. I will go towards the right side, and there is the tricky part. Okay, now I go towards the right. Okay, and I find okay, there is a land, but this land is already been visited, so I can't visit it again. So I will backtrack, and to maintain this visited, we will create a visited array. It will keep the track that how many land we already visited, so we don't visit it again, or it will create a cycle. Okay, so I will go back towards this one. Okay, now I will go toward upward again. This has already been visited, so I will backtrack here. Okay, I will backtrack here, then I will backtrack here again, then I will backtrack to this, then this one, and I will come back to here, my original position where I already been started, and I will go from here. I started to go towards the right. Okay, now I will try to go towards the down, but it has already been visited, and I can't go towards the left and upward. So the whole DFS is done, and I will, what I find at the last, I will find that this part is already been considered as one island. Okay, as you can see, my this part is visited. If you see that I visited, wait, let me erase this. As you can see, uh, first of all I start from here, so I marked it visited, then I go here. Okay, then from here I go here, then from here I go here, then from here I go here. Okay, then I backtrack from here, from then I will go backtrack to here, then I backtrack to here, then I visited this one, then I visited this one, then I visited this one, and then I visited this one, and then again I backtrack from here, then here, then here, then here, and I came back to this again. And as you can see, how many lands I covered? I covered this lands. Okay, and I consider this whole as one island. So that's how DFS will work. Now I will start exploring again. See, I first here in pseudocode I start to explore each of the cell, and when I start from this cell, I already visited this whole land. Okay, and I consider this as island. So again, when I visit this one, so I will not start exploring this land because I already consider this as a part of one island. Okay, so if there is another one, let's say this island, so this can be explored further because this is not a part of this island. Okay, so this island will be considered as another island, but it will not consider as a part of this island. Okay, and whenever I uh, whenever I traverse this land, so I will not explore it further because it has already been explored. So that's how this DFSs work. As you can see here, first of all, in pseudocode, I create a visitor array which will be keep the track of the lands which are already been covered and consider them as a part of an of any island. Okay, then I create a loop uh, which ith loop which will traverse from 0 to mth, which is row, and j which will be go which will traverse towards the column. Okay, and if a grid is a land, okay, first of all I check if a grid is a land and it is not visited. Okay, this does not mean if it is not visited. uh, this false will become true if when this not with this not. So I will create a DFS. I will start DFS. I will start traversing its neighbors. Okay, so this function will be called, and if I will check whether I and j is out of the boundary, it means I will only consider the I will only consider the cell or the land which is inside the m cross n boundary. I will not consider out of the boundaries. Okay, and I will also check whether it is not a water, because I will only traverse the land part, not the water part. Okay, or I will check whether it is visited or already visited or not. If a cell is already visited, so I will not traverse it further. I will simply return it. Okay, so I will simply return it, and if it is not any of these conditions, so I will simply mark. It means it is actually a land. Okay, it is actually a land. So I will mark it as I visited this land, and from that particular land I will start exploring other possible land that can be found. For example, let's say I start from here. Okay, it's a land I mark as visited, and I will start exploring it on the fourth side here. Let's say if it start from here, so I will start exploring it towards the right, up, down, and right. Okay, I will start exploring its neighbor, and I will check whether there is any particular land which can become a part of this island. Okay, if it's become a part of this island, so I will start exploring that also, and that all will particularly become an island, and this result part will be mark my island. Okay, this result will be mark my island. Like for example, if I start from this particular cell, this is the first cell which I traverse first. Okay, here I start from here, then it will explore this whole island, and it will consider it as a one island. So this result will increment by one. Okay, and and then later on I will check whether is there any other part then this can become an island. Then again that time also my result will be increment by one. Okay, so like for here in this example, this if I start from this point, this whole is considered as one island. Okay, and for later stages when I reach to this point, so this will be considered my second island, and the result will be again increment by one. Okay, and this will become my second island, and then and for the later stages again I will come here and I will start exploring this, and I will find this one land as a part of island, and this will be become my third island, and the result will again increment by plus one, and at last I will return the result, and that will be my answer. Okay, so let's code it. Okay, so first of all let's get the number of rows in m and number of columns in n. Okay, now we will start traversing our grid one by one from row to column. And now I will check whether the cell I am particularly traversing is a land or not. Okay, is a land or not. Here one indicating my land, and I will also create a visited array which will, let's create a pool. Okay, of m, which indicate here false indicate that okay no cell is visited for now. And now first of all I will check whether the grid is a land or not, and I again also and I also check whether it is visited or not. If it is not visited, so we can explore it. Okay, if it is not visited, so I can simply call the DFS function, and I can simply assume it as one island because this is a land which I never visited. Okay, I will also create a result which is initially 0, and at last I will simply return the result. Okay, now it's time to create this DFS function, and how many parameters it will take. It will first of all take the grid. Okay, now it will takes the cell which we are on currently, and the boundaries m cross n, and the visited array, the visited. Okay, let me pass this all in this function call. Okay, I will pass grid, then I say my current index, where I am currently in the current cell, this ing, which indicates where I am currently in which cell, and m and n, and the visited array. Okay, now I will check whether is the particular cell, is the index where I am currently is out of the boundary or not. First of all, I will check that, and I will check that if my ith or jth row is less than 0, it means I am out of the boundary. Okay, or my I is greater than or equal to m, or, or my z is greater than equal to n, it also means that I am out of the boundary. And if I am inside the boundary, then I will check whether the particular cell that I am visiting is it a water or not, is it water or not. If it is not water, it is a land. So whether we visited before or not, I will check that also. Okay, if any of this condition is satisfied, it means I don't have to visit this, I simply return. Okay, and if any of this condition is not satisfied, it means it's a land and we all not visited it. Okay, if any of this all condition that I have mentioned here, if it is not satisfied, it is guaranteed that the cell which we are now currently is never visited, and so we can simply visit it, and it's a land, so we simply visit it. Okay, and we start to visit its neighbor. Okay, we start visiting its neighbor. First of all, we will go towards the right. Okay, simply copy it, and I visited towards right. Now I can visit towards down, then I can go move towards left, and I can move towards up. Okay, so simply I visit all its neighbor, and I will backtrack whenever this condition is this condition will become false. Okay, so that's all the coding part. So let's try to run this code. Well, it's giving me the wrong answer. Okay, so here's the problem. I have to write here +1. I write it here -1. Okay, now it's giving me the right answer. Okay, so let's try to submit it. So it got submitted, as you can see. So this is all DFS approach. First of all, I simply check that whether the cell I am visited is a part of a grid or not. If it's not a part, so I simply return, or whether it is water or water cell. If the cell is a water, so I will not visit it. Or if it's not water, it is a land. So I simply check whether it is visited before or not. If it is visited before, so I will not visit it again, or it will create a loop. Okay, and if it's a land which is not visited, so I simply visit it, and I will start visiting its neighbor. I'm start checking whether any adjacent to that particular node, is there any land with, is there any land? So I will consider that as a part of this particular island, and I will create that whole as island, and I simply increment my result. So this is all about this question. And the time complexity of this code is m cross n, which is where m indicates your row and n indicates your column, because here I am creating a nested loop of m cross n, and this DFS function not affecting much to the time complexity, because if I already visited the array, okay, if I already visited the array in this function, so I will not visit it further in this particular loop. So I don't have to do much change. I will simply skip that particular part, because here in the visited array, if I already visited that particular index here in the DFS function, so I simply skip that part. Okay, so that's why the time complexity is just fixed to m cross n. So that's all for today. You will get the source code of this in the GitHub. You can check the description for the link. So I will meet you on the next video.